Here's a line of Python that looks harmless, but quietly destroys your list. You call append to add an item, then save the result back into your variable, and suddenly your whole list is gone, replaced by nothing. In this video, we'll see exactly how append grows a list, why it hands back none, and the one-line habit that keeps your data safe. To grow a list, Python gives us append. The syntax is fixed. There's no other form. You write the list name, then a dot, then the word append, then the item you want to add inside parentheses. The name before the dot is the object you're changing. The item inside the parentheses is what gets tagged onto the end. So if you kept a list of employees, you'd write employees.append with the string Anna in the parentheses to add Anna to the end. This adds exactly one item and makes the list one element longer. Let's make it concrete. Start with the list 2, 1, 3 and call append with 5. Python looks up that list and adds the object 5 onto the end. Now the list is 4 elements long. 2, 1, 3, 5. Notice what did not happen. We didn't make a copy and we didn't build a new list. We reached into the exact list already sitting in memory and changed it there. That's what mutation means. Same object, new contents. Here's the twist. Append is used purely for its side effect, and that side effect is changing the list. Once it has added the 5, its job is done, so it has nothing meaningful to give back. It returns none. That leads to a classic mistake, writing L equals L.append of 5. Python first runs the right-hand side, which does mutate the list, but then it takes what append returned, none, and binds the name L to that. Your freshly mutated list is thrown away, and L now points at none. You've destroyed the very list you were building. The right way is simple. Just call append on its own line. There's nothing worth saving, so don't assign it to anything. Watch it build up. Start again from 2, 1, 3. Call append with 5 and print the list. You see 2, 1, 3, 5. Call append with 5 again and print. Now you see 2, 1, 3, 5, 5. Each call mutates the same list, and the next call works on that already changed list. One more rule, append adds exactly one thing at a time. If you want to add a tuple, that's allowed, but it goes in as a single item, one object that happens to hold several values. Now trace a trickier example. One line at a time. We set L1 to a list holding the string array. L2 holds Amy, L3 holds do. Then L4 is set to L1 plus L2. Adding two lists concatenates them, just like joining strings, so L4 becomes a new list with two elements, re and Amy. Next line, L3.append of L4. The list that changes is L3, the one before the dot. We append a single item, whatever L4 is. Since L4 is the list read me, L3 becomes do, followed by the list read me. That appended item is one element that just happens to be a list. Last line, L is set to L1.append of L3. The right-hand side changes L1, not L3. L1 started as just re, and we append L3 onto its end. Remember, L3 is now do, followed by the list re, me, so L1 becomes re, followed by that entire nested list, and because append returns none, the name L on the left becomes none. So here's the habit to keep. Append grows a list by one item, mutating it in place, and then it returns none. It belongs to a family of functions used purely for their side effect. They change the object you call them on and hand back nothing. The moment you write L equals L.append, you have traded your list for none. So call these functions on their own line, let them do their quiet work, and never save what they return. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.